Hello everyone, welcome back to my channel. I'm Charlie. In my last video, I tried to use AI to remake this broken part of my tripod smartphone mount, but it failed. But I don't want to give it up, so because I really enjoyed that process. So I'm going to try a different approach. Instead of asking AI to model this whole part in one go, I'm going to break this part down into individual geometric features and evaluate how different large language models handle each one. Okay, so let's start. Okay, you can see that this broken part is actually much more complex than than I first thought. It has a lot of geometric features. As you can see, there are more than 10 features here. That made me think if I really want to test the actual modeling capability of a large language model, I shouldn't start with something this complex. So instead, I should start from the basic ones. I'm going to begin with the base plate. It is just this thin rectangular solid part. Okay, I have wrote my first version prompt. That is, use the Python library build123D to model the following geometric feature. Create a rectangular base plate. So let's see what's going on. So simple. Okay, so let me see. Well, that's great. Okay, it's really a very simple base plate, yeah, rectangular shape. But I think maybe I think we just don't know which parameter refers to which edge. I think maybe we can just ask AI to label every parameter. AI operator is not a good job for human. Oh my god. Endless waiting just for a rectangular shape. Is it the real end of human being? I don't think it's a good idea. I think it's the last time.
1 hour later.
Oh my god, it works. I can toggle it. Finally, we got a workable code. Can let me know which parameter is which edge. Okay, so now we took about 1 hour to ask AI make this rectangular shape, very basic rectangular shape. Okay, but with a good visibility of different parameters. I think it's very important for us, because if we don't know, we can't communicate with AI to create more geometric feature. I think it's enough. Okay, it's done. It just took me less than 20 minutes. Okay, I failed again in this experiment. Well, actually, I consider that if I break down all the geometric features, I can get better. But it seems, this experiment really made me more, understand, using AI to model the 3D structure is not a very practical method, because I have broke down the whole broken part into many individual geometric features. And I consider that I can just start from the very basic one, the base plate. The base plate. It is just a rectangular shape, solid shape. And I tried with the Claude and the ChatGPT, but the ChatGPT didn't perform very well, so I gave it up at first. And then I just used the Claude to do this experiment. Actually, the modeling work is great. In the very first turn, the Claude did it well. Just use the Build123D Python library to do the modeling work. But even it's just a tiny work, and it seems not very related to the spatial reasoning or understanding of geometric feature. But I think it revealed the Claude doesn't know very well about how to use this Python library to do the modeling work. And maybe I think this is just about the training. Yeah, I think maybe a refining on the specific documentation of this Python library, or maybe just connect to a specific MCP will helpful. I think so. But there are really many things to solve, many problems to solve to achieve the final requirement that just send some different angle view photos to the AI and let the AI know every geometric feature by itself, and then understand how to draw every geometric features one by one. I think it's really a big challenge for AI for now. And I think using AI to model the 3D structure is very inefficient. Because I just tried to model these broken part in my favorite CAD software, the Fusion 360, and it just took me about 20 minutes, less than 20 minutes. So you can see that using CAD software, the manual modeling is much faster than the AI. And especially for this precise modeling, I think the manual approach is better. It's much better. And I also find that even the AI can handle, can use this Python library very well. I think the human operator, just need many skills to the mechanical engineering or structural engineering. Because there are too many terms during the process. You need to know the precise name of every geometric feature, and it can let AI to understand you clearly. Okay, but I don't think everyone can know these professional terms and can express them precisely in words. So I think using AI to model 3D structure isn't a good choice, isn't a very practical choice for now. But this experiment is still worth exploring, because I still believe that AI will handle this in near future. The coding part is not the most difficult part, I think. The spatial reasoning and how to order the drawing process for every geometric feature is more difficult. And for human, it actually needs many years experience. So the experience is much more valuable. I still believe it will work in near future. Okay, maybe in about 2 years or 5 years. but I think I will do more experiment to test the real spatial reasoning ability of AI, not just the coding part. I think the coding part can be improved by some other approach, like using a MCP server, or just write a better prompt, just like for the dimension labeling, I can write some correct code samples in the prompt. Maybe I think the cloud will do it better. And I think if I have another broken part to fix, I think I will do it myself. Okay, so thanks for watching, and see you in the next one.